Question is, if mod z equals to 1, then he has given the complex number w equals to z minus I by z plus 1. Okay, the two conditions are given. Then what is the real part of w is? Okay, so now here if z is equals to a complex number x plus iy, where the real part of the complex number is x and the imaginary part of the complex number is y, then we can write it as z conjugate as x minus I y. Okay, if we add these two z and z conjugate, we'll obtain it is as z plus z conjugate equals to, and plus iy minus iy will cancel out, we get it as a 2x, and from this one the x can be written as z plus z conjugate by 2. Okay, so where x is nothing but the real part of z. Okay, we know that x is the real part of the z and y is the imaginary part of the z. Then the real part of a z can be written as complex number plus its conjugate by 2. Now which is the concept we need to use here? This concept we discussed in the properties of a conjugate. Okay, real part of a complex number can be represented as average of the complex number and its conjugate. Average of the complex number and its conjugate. Okay, right. Now what is asking? Real part of w. Okay, real part of w, we can write it is as w plus w conjugate by 2. Okay, w plus w conjugate by 2, where w equals to, I am replacing it as z minus 1 by z plus 1. Okay, plus z minus 1 by z plus 1 conjugate by 2. Okay, and here we need to discuss few properties over here, and which is equals to, we know that z1 by z2 whole conjugate can be written as z1 conjugate by z2 conjugate. Okay, now we can write it as z minus 1 by z plus 1 in plus, we can write as z minus 1 conjugate by z plus 1 conjugate by 2. Okay, and we have the another property. What it is? z1 plus z2 whole conjugate can be written as z1 conjugate plus z2 conjugate. Okay, now again we can write as z minus 1 by z plus 1 plus, now here over here z minus 1 conjugate, that means z conjugate minus 1 conjugate. A real number conjugate is a real number itself. Then denominator is z plus 1 conjugate can be written as z conjugate plus 1 conjugate by, we can write it as a 2. Okay, we can write by 2. Okay, if I am moving for the simplification over here, so then take the LCM for this one, then we can write it as real part of omega equals to, what we can write it as, we z minus 1 into z conjugate plus 1. Okay, plus z conjugate minus 1 into z plus 1 by 2 into z plus 1 into z conjugate plus 1. Okay, simply we are doing the LCM, then go with the simplification. What will get? Z into z conjugate plus z minus z conjugate minus 1, the resultant for this one, and next the resultant for this one is plus, means directly we can write as z into, sorry, z conjugate into z plus z conjugate minus z plus 1 by, okay, 2 into z plus 1 into z conjugate plus 1. Okay, right. So what it is? Plus z minus z minus z conjugate plus z conjugate Okay, and over here it is minus 1. Okay, minus 1 into plus 1, we can write it, this is as plus 1. Okay, we can write as, sorry, minus 1. Okay, here it is minus 1 into plus 1, it is minus 1. Okay, I can write this is as minus 1 over here. Okay, minus 1 over here. Then we can write it as z into z conjugate plus z conjugate into z. That means 2 times of z into z conjugate minus 2 by, okay, minus 2 by 2 into z plus 1 into z conjugate plus 1. So if we take 2 as a common, then we can write it as z into z conjugate minus 1 by 2 into z plus 1 into z conjugate plus 1, and 2 will get cancelled out. And what we'll get over here, so he has given that mod z equals to 1. Okay, he has given that the mod z equals to 1. So whenever in the examination, competitive exams, a mod z is given, always try to find out the square of the mod z. Then the square of the mod z equals to 1, which can be written as z into z conjugate, which is equals to 1. Now the z into z conjugate is 1, so we can write this is as 1 minus 1 by z plus 1 into z conjugate plus 1. Then 1 minus 1 equals to simply 0 by something, we'll obtain it is as 0. The resultant is option A is the correct one. We are obtaining it is as 0. Okay, this is the way of using the properties in the given question. So if we are able to identify the properties, then it is simple to us to solve this question.